This presentation is produced by Amugi, an international manufacturer of high-performance tools, including taps, end mills, thread mills, tool holders, work holders, and gauges. This presentation will demonstrate the high versatility of Amugi's machine cutting tools. The workpiece is pre-hardened steel at 32 Rockwell. All tools are clamped with either Amugi Shrink Fit or Amugi Power Grip tool holding systems. First, a slot will be produced in two halves. The first half will be cut with the plunging technique using an 80mm Time S-Cut insert style face mill. Time S-Cut inserts are designed with chip thinning geometry, which makes them ideal for high feed surface milling and high quality surface finishing. However, this plunging operation demonstrates another way Time S-Cut can be used. Whether it's high feed circular pocketing, high feed face milling, high quality surface finishing, or high volume roughing, Time S-Cut is a very good option. That kind of versatility is the theme of this presentation. The second half of the slot will be cut with the tricordial technique, using an Amugi 12mm 12 flute HSC jet cut solid carbide end mill. With this technique, there's no idle travel, which makes it a time-efficient process. Unlike conventional slot milling, the tool will not fan out at the tip, ensuring a true form while providing perfect control over slot size. Additionally, there's very little variation in torque and thermal loads, which is good for the tool and the part. It's also a technique that can be used in very hard materials. And this is important because conventional slot milling can only be done up to 45 or 50 Rockwell. All the advantages of tricordial milling are only available with a tool that can produce high performance and durability while climb and conventional milling. This isn't an easy thing to accomplish, but from the sound of the machine, you can probably tell that HSC Jet Cut is just such a tool. Next, a wave shape will be added to the slot using an Amugi multi-jet cut duplex end mill, which will be used extensively in this presentation. Notice the varying radial depth of cut has little impact on the sound of the machine. This indicates that the operation is well inside the performance envelope of the tool. Now, the same 12 flute HSC jet cut end mill that was used in the tricordial procedure will continue machining the wave shape slot. The procedure will start with a feed rate of 70 inches per minute, which looks pretty conventional. In fact, it probably looks just like something you've recently seen in your own machine shop or one you visited. Then the program will gradually be optimized until machining speed reaches 800 inches per minute, which is really fast. The plume of chips behind the tool gives us some idea just how much work is really happening here. One key factor in reaching these speeds is the flute geometry, because with 12 flutes, the chip load is a third what it would be with a 4 flute end mill. The final pass will be slowed down to enhance surface finish. So, with this one tool, it's possible to do climb and conventional milling, roughing, high-speed machining, and finishing. Multi-jet cut duplex will now be used to produce the same shape from the material on either side of the wave shape slot. But the technique used to make each side will be completely different, and this will illustrate why the tool is called duplex. Right now, cutting on the profile, this 10mm tool is removing 10 cubic inches per minute. If we scale that up, the same tool in 20mm can turn 36 cubic inches of steel into a pile of chips in 60 seconds. You probably can't make money just turning metal into chips, but it is really cool, and it highlights the profitable time savings this high productivity tool offers. Multi-jet cut duplex will now produce some chamfers, tapers, and radii. Why is it called duplex? This is because it has very different geometries on the face and on the profile. The profile is optimized for high productivity machining, as we just saw, and the face is optimized for high-speed machining. The HSC capabilities of multi-jet cut duplex will be demonstrated when this same taper shape is produced on the other side of the wave slot. The first external side of the component was produced with an HPC-style process, milling with the profile of the multi-jet cut duplex. The second side will be produced with an HSC-style process, milling with the face cutting edge. The axial depth is 31 thousandths. With this relatively small depth of cut, it's possible to use the tool with a cutting speed of 1,000 surface feet per minute and a feed rate of 400 inches per minute. The slanted surface on the component will be produced with a profile milling process. And now the same chamfering and radii operations that finished the first side will be performed on the second side. So far we've seen multi-jet cut perform HPC profile milling, milling with varying radial depths, HSC face milling, finishing, chamfering, tapers, radii. That's a lot of utility from one tool, but there's still more that can be done. Now the duplex will be used to demonstrate pocketing. All duplex cutters come with internal coolant supply IKZ holes, which improves chip evacuation in full slot milling and pocketing. As can be seen here, multi-jet cut duplex produces small, easy-to-handle chips, all of which are easily ejected from the pocket. Now, a high-quality surface finish will be achieved using the same time S cut which started the demonstration with a plunging operation. So, time S cut can be used for high-volume roughing as well as finishing jobs. A superior finish quality is made possible by the large radius on the face cutting edges. This geometry is often referred to as chip thinning, and basically means that the cutting edges have an eased entry and exit from the material, reducing vibration and producing a very smooth cut. A high heat-resistant TIALN coating permits very high cutting speeds. Time S cut can often operate nearing 1,000 surface feet per minute. Here, time S cut is being used to prepare the end of the material for the following machining operations. Now a deep slot will be cut, again using multi-jet cut duplex. Here it achieves a cutting depth of 1.5 times diameter, and thanks to its reduced neck, a total depth of 3 times diameter, all while cutting at 625 surface feet per minute and 60 inches per minute. The next operation will further highlight the duplex nature of this milling cutter. After some preparatory milling, a tapered hexagon will be produced on the front side of the component using HPC profile milling and the machine's 5-axis. Now a sphere is being produced with an HSC face milling process and only 3-axis. In switching from HPC to HSC, the cutting speed is nearly doubled. We now have a cutting speed of 1,030 surface feet and a feed rate of 400 inches per minute. After this milling is finished, some thread milling will be demonstrated. The milling portion of this presentation really highlights the versatility and performance of Amugi milling cutters. Time S Cut demonstrated high volume roughing and high quality finishing, and is also capable of high feed surface milling. Also demonstrated was HSC Jet Cut, climb and conventional milling at 800 inches per minute, a tool that's also a very capable finishing cutter. Multi-Jet Cut Duplex performed extraordinary HPC and HSC work cycles and reached down to 3 times diameter. Think about what combining versatile, intelligent tools such as these with clever machining techniques like tricordial milling can do to reduce tool changes and idle machine time. Slotting, pocketing, face milling, profile milling, long reach, hard material, finishing, HPC, HSC, dynamic machining in 3 and 5-axis, all done with just 3 tools. That's really cool. The first thread mill to be demonstrated requires a pre-drilled hole, but will produce the full thread form in a single revolution. Some of its features are versatility. It can thread, chamfer, cut right hand, left hand, and STI threads, all with a single tool. Also its speed. It can produce a full 2 times D thread form in a single revolution plus chamfer in only 4 seconds. And of course its process security. Because the tool is smaller than the diameter of the hole, if ever there's a tool failure, you can simply remove the tool, replace it, and continue machining. The next thread mill is very interesting because it doesn't require a pre-drilled hole. As you can see, the tool will machine its own hole while producing the thread form. This tool has excellent versatility because it's able to drill, thread mill, and cut right hand, left hand, and STI threads down to a depth of 2 times diameter. It also has versatility in the materials it can machine. In fact, the spiral flute version of this tool can machine materials up to 38 Rockwell, and the straight flute version materials up to 60 Rockwell. Because it can do so many things, this will help economize tool storage in the machine. Additionally, the overall operation time can be limited because tool change time is reduced. And it offers the same process security that all thread milling does. And as you can see it machining there, it has very good chip evacuation for high process security and long tool life. And finally, after preparing a hole, we'll demonstrate the very versatile single plane thread mill. A single plane thread mill is versatile because it can produce multiple pitches and diameters. It can cut left hand, right hand, and STI threads, all with the same tool. Another unique thing about a single plane thread mill is that it has the lowest radial cutting pressure of all threading techniques. This can solve flexing issues in a variety of circumstances, including long reach scenarios. It also has very good tool life in hard material. A single plane cutter also has lower production cost because there's only one cutting edge to manufacture. This means it has an economical purchase price. And of course, the single plane thread mill offers the same high process security that all other thread milling techniques do. So this was a lot of interesting machining. If you have any questions about the tools or procedures used in this video, feel free to contact us by phone or email. Thanks for watching.